The best solid-state battery cells validated by a major automaker have shown about 600 cycles. 600. Donut Lab claims 100,000. That's not an improvement. That's not even an exaggeration. That's 166 times better than anything the entire industry has demonstrated. And they want you to just believe them. In a bit, I'll show you why the math makes this physically impossible. Now add the rest of their claims. 5-minute charging, 11C charge rates, around 400 watt-hours per kilogram. A lithium-free solid-state battery that supposedly outperforms everything the industry has spent decades building. In summary, fast, dense, long-lasting, cheap to integrate, no compromises. Even if half of that is true, it doesn't just improve batteries, it rewrites the rules of electric vehicles, consumer electronics, maybe energy storage itself, and it would be the biggest leap in battery technology in modern history. But here's the problem. When you actually run the physics on those numbers, the story starts to fall apart and their claims start to look physically impossible. Let's break it down. What is a cycle? Before we get into the physics problem here, we need to talk about what that 100,000 cycle claim actually means. Because the number sounds impressive, but most people don't have a mental reference point for it. A battery cycle is simple. One full charge and one full discharge. Charge it to 100%, drain it back down, that's one cycle. Your phone battery is usually designed for around 500 to 1,000 cycles before noticeable degradation starts to kick in. That's why after about 2 or 3 years, your battery life starts getting noticeably worse. The chemistry simply wears out. Electric vehicles do a bit better. A Tesla battery pack typically lasts somewhere around 1,500 to 3,000 cycles before significant degradation. That's enough for many years of driving, but eventually, the battery still loses capacity. Now let's move up the ladder. Solid-state batteries, the technology companies are racing to commercialize right now, are still in the prototype stage. The best lab-tested examples so far, including cells from companies like Factorial, backed by Stellantis and Mercedes, have validated around 600 cycles. That's considered impressive for solid-state chemistry because the materials are still difficult to stabilize over long periods. Now compare that with what Donut Lab is claiming. 100,000 cycles. That's not a small improvement. That's not even a big improvement. That's a completely different universe. Because 100,000 cycles means something extraordinary in real life. It means charging the battery every single day for 274 years. Let that sink in for a moment. To put this in perspective, if you charged a Donut Lab battery every single day, it would outlast you, your children, and your grandchildren. That should immediately raise an eyebrow. And that's where the skepticism starts. Because when you look at the rest of Donut Lab's claims, the charging speed, the energy density, the chemistry, something strange happens. The specs start contradicting each other. Why the specs contradict each other? Here's the thing about batteries. Every battery design is a series of trade-offs. You can push for higher energy density. You can push for faster charging. You can push for a longer lifespan. But pushing all of them at once is where the physics starts pushing back. And that's exactly where Donut Lab's claims start to look strange. Let's start with energy density. Donut Lab claims around 400 watt-hours per kilogram. That's extremely high. To reach numbers like that, batteries typically use thicker electrodes packed with more active material. More material means more stored energy. But thicker electrodes create a problem. Lithium ions have to travel longer distances through the material during charging and discharging. That slows ion transport down and makes fast charging much harder. Now compare that with Donut Lab's second claim. They say the battery can charge at around 11C. That means the entire battery can theoretically charge in roughly 5 minutes. Charging that fast requires the exact opposite design. Fast-charging batteries usually rely on thin electrodes so ions can move quickly. Thin electrodes reduce resistance and heat buildup during high current charging, but thin electrodes store less energy. Which means high energy density and ultra-fast charging are usually competing design goals. Now add the third claim, 100,000 cycles. Fast charging is incredibly stressful for batteries. At high charge rates, ions slam into the electrode materials faster than the chemistry can comfortably handle. That causes microscopic damage over time. Even the best lithium-ion cells degrade faster when repeatedly fast charged. So claiming extreme charging speed and extreme cycle life at the same time raises another major contradiction. And we're not the only ones pointing this out. MIT professor Shirley Meng, one of the world's leading battery scientists, has described the challenges of solid-state battery development as very high. SVOLT CEO Yang Hongshan put it bluntly when discussing similar claims in the industry. He said all the parameters are contradictory, because each improvement usually comes with a cost somewhere else. Which brings us to the simplest way to think about it. It's like saying you built a car that goes 300 miles per hour, gets 100 miles per gallon, seats 8 people, and costs $15,000. Each spec individually is plausible. All of them simultaneously? That breaks physics. And that's why we immediately start asking a different question. Not, is this impressive? But what exactly was tested? What the VTT report didn't test. So if the specs themselves raise questions, the next logical place to look is the testing. Donut Lab points to a validation report from VTT, the Technical Research Center of Finland. That's a respected independent research organization, and their involvement adds credibility. But when you actually read the report, something interesting appears. The test focused on one specific claim: fast charging. VTT ran a series of tests to measure how quickly the battery could charge and discharge under controlled conditions. The results showed the cell could handle extremely high charge rates, including around 11 C, which lines up with Donut Lab's claim of roughly 5 to 7 minute charging. That part of the claim appears to hold up under the conditions tested. But here's the catch. The report didn't test cycle life. Not even close. To validate a claim like 100,000 cycles, you would need long-term testing that runs thousands, sometimes tens of thousands, of charge and discharge cycles while carefully measuring degradation. That kind of testing can take months or even years. The VTT report didn't do that. Instead, it ran only a limited number of cycles, just enough to demonstrate charging performance. And that's not the only missing piece. The report also doesn't include the cell's weight or dimensions. That means one of Donut Lab's biggest claims, the 400 watt-hours per kilogram energy density, cannot actually be verified from the data provided. Without mass, you can't calculate energy density. Which leaves two of the biggest claims: cycle life and energy density, completely unverified by the report. And there's another detail worth noting. Donut Lab has openly said they're releasing information about the battery in stages, gradually sharing new results over time, which leads to an uncomfortable conclusion. They tested the one claim that's easiest to prove, fast charging, and left the two hardest claims completely untouched. And that raises a bigger question, because if this battery is truly as revolutionary as claimed, why aren't the most important numbers being tested first? What real companies are doing? Now here's where things get really interesting. If Donut Lab actually solved all these problems at once, they didn't just beat a few startups. They beat the entire battery industry, and that industry includes companies that have spent decades and billions of dollars chasing the exact same goal. Take Toyota, for example. They've been researching solid-state batteries for more than a decade. Massive R&D budgets, dedicated labs, partnerships with universities and suppliers across the world. Their current roadmap? Mass production sometime around 2030. Next, look at Samsung SDI, another global battery giant. Deep materials science expertise, huge manufacturing infrastructure. Their solid-state timeline around 2027 for commercial production. Then there's CATL, the largest battery manufacturer in the world. They're targeting roughly the same window, somewhere around 2027, as they slowly scale solid-state technology from lab prototypes toward real vehicles. And they're not alone. BYD, one of the biggest EV manufacturers on the planet, is also aiming for small batch production around 2027. Then you have QuantumScape. They've spent more than a decade working on solid-state cells, billions in funding. Partnerships with automakers, entire research teams focused on solving the same stability problems. In February 2026, they finally opened their pilot production line, a huge milestone after years of development. And even they aren't claiming anything close to what Donut Lab is promising. Not 400 watt-hours per kilogram, not 5-minute charging, not 100,000 cycles, certainly not all of those things at once. And that's because they understand something fundamental about battery development. Progress is slow, incremental, one breakthrough at a time. Which is why this situation raises eyebrows across the industry. Toyota has spent over a decade and billions of dollars on solid-state batteries. They're targeting 2030. And you're telling me a company founded in August 2024 beat them all? Come on. Now, to be clear, startups can absolutely innovate faster than big corporations. That happens all the time. But when a brand new company claims to have solved every major problem in battery science simultaneously, industry experts start looking very carefully at the data. And that's where the story takes another turn. Because when experts examined the actual test results, they noticed something subtle, but extremely important. The real tell. Here's the part that really makes experts pause. When analyzing the VTT results, experts noticed the battery's voltage curve, the way voltage changes during charge and discharge, looks exactly like a standard Li-N-MC lithium-ion cell. That's significant. Voltage curves are like a chemical fingerprint. They reveal what's actually happening inside the battery. If Donut Lab's cell were truly lithium-free and solid-state, the curve would look different. It would behave in ways consistent with a new chemistry, not an existing lithium-ion design. Instead, the data tells a much simpler story. The battery performs well in fast charging, yes. But if it's actually Li-N-MC, the 100,000 cycle claim isn't just unproven, it's physically impossible with that chemistry. And yet, this detail is barely being discussed. It's the kind of subtle clue that separates real breakthroughs from marketing spin. Because at the end of the day, numbers don't lie, but claims without verification do. In truth, 100,000 cycles isn't ambitious. It isn't optimistic. It's a number designed to make headlines and attract investors. And until Donut Lab lets an independent lab run thousands of cycles on their cell and publish the degradation data, it's just a number on a slide, nothing more. Extraordinary claims demand extraordinary proof. Until all their claims are data-proven, it's just marketing. If you want to see exactly how the VTT report stacks up, what it hides, and the subtle red flags that almost no one is talking about, subscribe now and turn on your notifications so you don't miss the next video.